Lesson 5, Coordinate Geometry, the gradient point form of a line. Theory. Prove that the equation of a line between the points x1, y1 and x2, y2 is given by y minus y1 equals m outside of x minus x1. First of all, we'll draw a line. Okay, so we'll just draw a line through here, some line. It's supposed to be straight. Now on that, we'll put a point here and a point here, and we'll call this one x1, y1, this one x2, y2. So the gradient of that line is the difference in the y values, y2 minus y1 over x2 minus x1. Now multiplying both sides by x2 minus x1, we get y2 minus y1 is equal to m outside of x2 minus x1. Now x2, y2 is a specific point, but if we make this a variable point along the line here, so in other words, this now goes out, becomes a variable point, then all we need to do is replace the y2 and the x2 with y and x. So the equation now becomes y minus y1 equals m outside of x minus x1. And that's the equation of the line in the gradient point form. Right, now here are some examples. First one, find the equation of the line that passes through the point minus 1, 3 and 2, negative 4. Now clearly what we need to do is determine the gradient, but before we do that, we're just going to plot these points very, very roughly. Now the point minus 1, 3 is about there, minus 1, 3, and 2, negative 4. Let's bring that up a bit. 1, 2, negative 4, say down there somewhere. And by doing that, you can see you're going to have a negative gradient, which is a nice little check step. Alright, so let's work out the gradient first. So gradient is equal to the difference in the y values. That's negative 4, take away 3, all over 2, take away negative 1. And that gives me negative 7 over 3. Right, now using that form, that's y minus y1 equals m outside of x minus x1. And we'll just put in the points. Now you can put either point. I'll choose this one. We could equally choose the other one. So putting that in, you get y minus 3 equals minus 7 over 3 into x minus negative 1. Now taking the 3 across to this side, I'm going to put this in what's called the general form of the line. So multiplying both sides by 3, we'll have a 3 here. It'll be y minus 3 equals a minus 7 outside of x. We'll change that to plus 1. Removing the brackets, we get 3y minus 9 equals minus 7x minus 7. By taking these all across the other side, I get 7x plus 3y minus 2 is equal to 0. Now that's called the general form of the line when you've got them all on one side. Alright, general form. Alright, example 2, a algebraic one. Find the equation of the line that passes through the point 2AP, AP squared, and 2AQ, AQ squared. Now going on as before, looking at the gradient, we're going to have m equals difference in the y values, AP squared minus AQ squared over 2AP minus 2AQ, which is A outside of P squared minus Q squared, all over 2A into P minus Q. Now this is the difference of two squares, so that's going to be A outside of P minus Q, P plus Q, all over 2A into P minus Q. The A's go out, and these P minus Q's go out, and you're simply left with P plus Q over 2. So we have y minus y1, so y minus AP squared equals P plus Q on 2 times x minus 2AP. So this equals P plus Q over 2 x minus 2AP times P plus Q over 2. So this becomes P plus Q over 2x minus, now this will cancel. Only removing the brackets, we're going to get minus AP squared minus APQ. And we can see there that these AP squares will cancel. And we get the final result, which is P plus Q on 2x minus APQ. And this is quite an important formula. In fact, it comes from the parabola x squared equals 4ay, and this is the equation of the chord joining these 2 points. So it's an important one which we've derived.